Good evening, Tropical on Rails. It feels like magic, actually, being here, staying on this stage of this amazing conference, being in Brazil, thousands of kilometers away from every place on Earth I ever considered my home. But even though Brazil geographically was always far away from me, it always has some place in my heart, I should better say my feet, because you probably guess why, right? I'm a big fan of football. And the Brazil team of late 90s, early 2000s is one of the reasons for that. I still remember the player numbers, like number 6, Roberto Carlos, number 10, Rivaldo, and my favorite one, number 9, the true Ronaldo. Yeah, so I arrived to São Paulo. The dream came true. I met some people here, locals and visitors, and they were giving me a lot of advice. Not every advice was bad, but it sounded like, oh, I should probably enjoy the city and the country through the window of an Uber. But that's no way, not my way. So I did quite the opposite. And I decided I need to enjoy this country. I came for the reason here, right? So I took a subway. I grabbed some good food and drink. And I visited the place the second reason I came here, actually, the Museu de Futebol. Highly recommend. And I met my heroes there. And that's all because of you, the Tropical on Rails, the organizers, the sponsors, the volunteers, and you all who came here to celebrate this event together with all who traveled a lot and who now I heard a lot of our speakers who came here for the first time and attendees, and they will say, oh, I will definitely come back. And I should say the same. Yes, this conference and this country is definitely on the list of countries I will be coming back whenever I can. So, now the keynote. It's complicated. Okay. Sorry, I should have thought about it. All right, so the topic I want to discuss today, I called it from 1 to 2, or that means that getting from 1 to 2 in the lifespan of a Ruby on Rails project, where point 1 is the initial launch. So we're talking about what happens when you launch the project, when you turn your idea into some product that you started getting users, and how to reach the point 2, which is, we'll get to that in a minute. Let's forget about Rails and web development for a second and focus on the theme of my keynote, which is space. And it's not a coincidence, not just because I'm from Mars, but because it's almost exactly 65 years since the first man reached the space. Well, 65 years minus 2 days, or 1 day, depending on the time zone. So, yeah. What was the point, where was the points 0, 1, and 2 in the history of space exploration? Let's talk about them first, and then switch back to software development. So, point 0, very long time ago, that's the idea. That's just the theory behind the future product, the rocket equation, and other theoretical grounds that actually made possible point 1. And point 1 is the launch of the first satellite, Sputnik. Just 80-something kilograms of metal for antennas and a radio transmitter that were sending a signal for a few weeks before it died. That's it. That was the MVP, because it proved that we can deliver something to orbit. But the fact that we can deliver something doesn't mean that we will have users, right? And that's the importance of point 2. Same rocket, basically. But now we have a human in it. And around that human, we have a life support system, a recovery plan, mission control, backups for the backups. Sputnik proof you can reach orbit. But Gagarin, or should I say Korolev, the engineer behind it, prove you can bring a human to space and back alive. That's important. The rocket barely changed, but everything around it did. So back to the topic. What do you need to do with your project, your code base, and everything around it to move from the initial launch to putting humans in, like putting real users, real load, real money, while keeping shipping features and whatever your users want? Think about it for a minute, while I'll dedicate some time to properly introducing myself, because we haven't done that yet. Well, I believe Sirdas told a lot. Well, yeah. So my name is Vladimir. You can call me Vova. I should probably add a Portuguese version of my pronunciation to this. Read me, since I want to come back. You may seen me on GitHub, where my handle is Palcan, also works as the way to call me. And I work on many projects like Anycable, TestPro, Faction Policy. The list is long. I don't have that much time. And speaking of I only got the part of what Sirdas said, but I want to add to it. He mentioned that I wrote an email speaking about football, maybe we're going to play. And do you know, I probably suggested, how should we split the teams, the rivals in that game. Do you have any ideas? Okay, it's RSpec and Minitest. So next time, I'm going to be kind of hiring players for Team RSpec, but I need a Minitest rival, maybe Pavel, I don't know. So yeah, let's keep it for next time. All right, continue. Okay. Our new website doesn't look good on the screen. Bad contrast. So I work at Martians. We are the DevTools consultancy. Thank you. And I lead the backend team, and I help our team to grow and help startups to ship and scale. But basically, what I do is I'm helping companies to get from 1 to 2. That's what I'm talking about today. And last year, we already participated at Tropical on Rails. We had 2 participants. Not everyone came. But anyway, this year, we have at least, I would say, 4 participants. And, we can continue that, right? So next year, we must bring 8 people, to double again. And that's tricky. We mostly base in other continents, and travel is expensive and long time required. So there is a solution. We need to start hiring people in the region, right? And now, after just a few days spent here around you, I think that's pretty much possible because this community has a lot of talent. And we should definitely consider borrowing some of it into our Martian squad. So yeah, you already mentioned that, so we're hiring sometimes. But we have some restrictions, and just to make it clear, reach out directly to me if you have questions. So, you have a content. It's a reference-based hiring, and now all of you have a reference as me. All right, let's get back to talk. Or should I say, поехали? All right, Ruby on Rails. One-person framework. That's true. We talked about it all the conference. It's the most optimized framework, the most optimized tool to get from idea to MVP or wherever. You run Rails new, you get a database, an authentication, you have Hotwire for front end, you have Kamal for deployment, everything you need. Like Marcus said, integration beats collection. That's why it's easy to get to 1. You ship, you iterate, you reach orbit. Rails extremely good in that. But what happens after that? What's the life after point 1? The same things that make it easier to get point 1 could make getting to next milestone much trickier. Why? Because you're not one person anymore. You have a team. You have customers. You have a production database that you're scared of touching and corrupting. Simple problems become hard at scale. So Rails gets you to space, but how to survive they come back alive? I've been circling this question for a while. Lately, at San Francisco Ruby conference, I've been giving a talk also related about to Rails, future, whatever. But the part of it was kind of the research of the community demands, community requests. What do Rails developers want from the framework and why? And based on the answers, based on the results of this research, I grouped all the Rails users into 4 categories. The first one is a kind of pre-Rails new users, or just early adopters of Rails. Those who not yet sure they're going to use Rails, they just considering it for their product. Then we have makers who build their first version. Then we have growing startups who already built something, got users, and keep growing. And then we have the whole universe of big Rails company of different sizes, from Shopify, Intercom, and Gusta to WAP and others. So not as big, but already big. And while working on that talk, I actually came up with the idea for this keynote because I've decided that, well, this group, 1 to 2, was the most attention, because that's actually the most tricky time in the timeline of your product and your application. Growing startups, right? When I was in San Francisco, I just put this number 2 randomly. I had no idea what does it even mean. Right? What's the point 2? How a growing startup becomes a grown-up, right? What's the difference? And we should take a look at this question from 2 perspectives, product-wise and software-wise. Though they're 2 sides of the same coin, kind of, but we must consider both of them. And let's talk about the product side first. So recently I learned about a new concept. Well, the concept is not new, but I was just, I'm not a business person. I don't read business books. But the concept of product market fit turned out to be very relevant to what I was researching regarding the software evolution, the code base evolution. So the team at Martians recently published this methodology of scoring projects with regards to their level, like product market fit level. Not just some vague idea, what is your product market fit, but numbers, well-defined metrics, calculable, easier to interpret, and easy to use to define priorities and next steps. So these are different PMF levels. And the level that's most interesting for us today is called early PMF. That's when you got enough traction, got enough users, and your growth probably slows down, or maybe speeds up, depending on the product, actually. But that's where you need to start thinking more about stability. Scale what's working and don't break what's working. Because you need to keep retention high. You don't want to lose your users. And that's highly coupled with the underlying software, because that's your foundation. And this relationship between the product and the software that runs it also could be kind of separated as a different concept. And I decided to call this concept as software product fit, or SPF, something that people use to protect themselves from sun. I don't know what it is. But luckily, these days in São Paulo, I don't need it. I like the weather. So, yeah, what is SPF, or software product fit? So the concept that describes how software adapts to the growing demand of the product, like in any sense, users, features, load. How software characteristics affect your product market fit. And we can draw the chart showing the problem that usually happens when the product grows faster than the software that runs it. We have the gap between those two. That's kind of a shaky foundation that you build a product on top. Yes, you can deliver feature without thinking about the quality of your code base and your processes and whatever. You can survive with this mode for some time, but eventually you just doing a highly risky, gig. So that's the problem here. When you don't pay attention to your code base, you just keep delivering whatever it means, whatever it takes. It slows down the product growth because every feature is more expensive. Every incident takes longer to recover. Every new hire takes longer to onboard. So the code base if the code base can't catch up with the product needs, the product falls apart. And that leads us to the axiom. Your product can't outgrow your code base. You cannot become the market leader using the same code base you used to launch your product. You cannot put a human on the Sputnik and deliver it to space, right? So we need to figure out what usually stops a Rails code base from keeping up with the product. What are the typical symptoms of that or growing pains? And we can learn about them from ourselves, from developers. So there are some quotes I also collected back in the days during the research. So we have a lot of sources actually of feedback regarding the framework and the ecosystem. We have Rails community survey, we have Reddit threads, we have personal connections because that's why we go to conferences to talk to each other. And what I found that Rails developers are pretty consistent in the complaints they have regarding the struggles of getting to the point 2 of living in the after 1 stage. And those complaints could be also classified into 2 groups. They either talking about maintainability or scalability. So maintainability defines the cost of change over time, the cost of fixing a bug, the cost of understanding the code base, and so on. And that's one of the vital characteristics of the code base, of the software. That's the health metrics. Scalability has 2 meanings. First one is like kind of a straightforward. It's about performance, how much traffic you can handle, how much user, how much data, and so on. And the second one is actually the scalability of the team and of the processes you have. How do you organize code the way that engineers working on different features do not step on each other? How to resolve conflicts and so on? How to keep everyone keep everyone productive? And these 2 concepts, maintainability and scalability, of course, related to each other, and they form the requirements for what needs to reach point 2, because that's maintainable, scalable software is the foundation that you use to grow your product, to go beyond this initial, growth period. And in this talk, the rest of the talk, I've been 10 minutes into it, I want to talk about maintainability because it's closer to code, to the code base, not to the servers, platforms, and so on, because that's my area, that's my passion. I'm a big fan of maintainable software, whatever that would mean. It's probably a matter of taste, but anyway, you're going to learn in a second. So, and I want to demonstrate what does it mean to improve the maintainability one tiny step at a time by the real example, very recent example. I had a chance to work on a project that just reached point 1, the initial launch. They got some users, and they discovered some problems right away. That's very good, because if you do not discover problems after the launch, probably your users don't use your product. So that's a story about the project called Fix It, and that's the moment I need to wear this hat. All right. Okay, so it's an online learning platform, lectures, students, teachers, some dashboards. It's a greenfield Rails app. We built it from scratch in just a few weeks, and Sviat was responsible for that mostly. That's why we have Rails and Inertia as the front-end stack, and everything was built very well. But still, we had some issues, and I joined the project because Sviat was busy with preparing his workshop and to deal with some post-launch issues. And the issue we found that, like we have this 500 undefined column, whatever. That's actually a very typical thing. Let's take a look at the code that caused the issue. So it's a typical Rails controller. I would say it's a Rails way controller because we don't have any fancy abstractions. We just take parameters, take the relation. We even use current attributes here. So the only optimization is this exclamation marks. That's micro optimizations from Svet, or maybe his AI agent. I don't know. So anyway, this code is very basic, but it had a wrong assumption that every possible sort field has a dedicated column in the database table, and we found that, someone added a new column for some virtual attribute, and it blew up. Well, that's okay. We're going to fix that. But I wondered why we ended up with this situation, what caused it, actually. And the reason is simple. It's just technical debt. We had this pattern introduced once for some simple use case for another controller. Then for the second controller, which is, okay, copy pasting. We already have this in the code base, we're using this pattern. Then finally we reached the controller that broke. And I'm not going to tell you that copy pasting and duplicating is bad. It's actually good. When you just at the 0 to 1 phase, you don't need to invest in anything beyond, plain Rails, Ruby code. Copy, paste, do whatever you want. Your goal is to prove that you can launch the product and not to make it 100% stable. So that's fine. But now we need to figure out what to do next. And one more point about this particular code, which I found interesting. So I assume that the front end, as I said, front end added a new column. We do not have explicit structure for filtering or sorting here. And no tests were added for the backend when the new column were added, because we already had 100% coverage. That's a caveat of the code like that has no clear contrast between front end and back end, no clear structure, that it's easier to get 100% coverage and still have 500 errors in production. So I decided to react early, to prepare, to make a tiny step towards point 2. Not just fix the bug in place, it could be easy, but introduce something that would prevent such bugs to reappear in the future for the similar logic, right? That's how you introduce stability into your kind of code base. So what I did exactly that. So I took a book, I wrote it once, and I never read it. So I decided, okay, I remember there is some chapter on, handling user inputs. Oh, right, I found it. Page 209. Interesting. Here it's 208. No, 209. It works. Right, same version. So the pattern, filter object. There's an object responsible, blah, blah, blah. So it's some kind of it's just an encapsulation of some repeatable pattern into a standalone object, standalone abstraction that could be used like in controllers, for example. And this is how a pattern described in the book would look in the code base. So instead of all this direct params tracking and calling where or whatever, we just create an object, delegate all the filtering, sorting, and transforming the relation to this object, and that's it. That would be pretty much simple. But that doesn't look like an established pattern in the code base. We haven't had anything like that. So I decided to go further, and I introduced a helper method. And the idea behind this helper method is actually to mimic the already existing pagey helper, because the behavior is about the same. That's the same thing. We pass the relation in, and we get the relation out and some metadata. So that's the thing about maintainability. It also implies, better maintainability implies introducing or following the conventions. You either follow the convention you already have in the code base or introduce a new one. That's why you reduce like conceptual overhead of the code base. Yeah, inside this filtering helper, there is a very dirty magic with metaprogramming. You don't need to care about it. I wrote it, I maintain it, it works. I've tested it. But you can use it, and you should just know how to use it. You don't look inside the paging helper as well, right? So that's the idea behind it. And let's take a look at the filter object itself. So we introduced the concept of filter object. And I used a gem called Rubanak. It's one of my gems, also extracted from a Rails monolith back in the days. It provides you kind of pattern matching looking DSL for defining how to treat incoming parameters and how to transform data based on them. And it allows you to track what's being used. And it also has a clear and defined schema of what's available. We extended it with some custom stuff and so on. Oh, that's not a deep technical talk, so I'm not going to explain all the code. What's good about separating the object, as we also separate tests. Now we have faster unit tests for the filter object, and we don't worry about having a lot of them because they are fast, but we can cover all the edge cases and have them as a specification for this filtering feature. So filter object is a member of the presentation level. It's not your backend, it's something that communicates directly with the front end. And this way we just make this communication well-defined and written. And from the controller level, we only have one spec to verify the contract. Oh, we call this request, and we know that calling this request filters this data using this filter. That's it. And from now on, whenever we need to introduce new logic to filters, sorters, whatever, we just touch the filter object and we never touch the controller again. It stays responsible only for coordinating actions based on the user request. And that's the responsibility of the controller, not dealing with filtering or whatever. So we also separate concerns. And one interesting side effect, but it was not a side effect, actually intentional. We also improve the coordination between front end and back end. So we use inertia, already mentioned, right? And we use TypeScript and React on the front end. And we use the typelizer gem that allows you to extract schema, like TypeScript definitions from Ruby objects. So what we do here, we make filter objects typelizer compatible, and we provide the structure of the filtering to the front end. So the bug we discussed initially, the bug of adding a column that is not supported by filtering, is not possible now, because front end cannot use any sort field that is not defined in a filter object. The TypeScript will just raise an error during the check, if you have a check on your CI, of course. And that's another kind of additional benefit of introducing a new concept, a dedicated concept for a repeatable functionality. So let's summarize what this refactoring gave us. So we extracted an abstraction layer, we introduced a convention, so now we know if we want to add similar functionality, what to do. We do not look at the controller and think how to treat params. We just create a filter object and use it in the controller using the helper. That's it. And we also improve stability and the developer experience by converting Ruby information to TypeScript. So, yeah, that's just a small step towards maintainability, like better maintainability. But that's how we reach point 2, one small step at a time. It's not a large-scale project. Oh, we expect to growth, let's rewrite everything in Rust. That's the improvement driven by your experience, by bugs you fixed, by PRs that took months to emerge, but whatever reflection you can apply and turn into some new architecture concept is how you reach the next step. And we were talking about a lot of small steps like that during the conference. Though they're all the examples of the same thing. All of this are examples of preparing for the next stage, for the next level in the product development. So it's not only about architecture and patterns, it's probably about some tiny things as well, but you need to keep them in mind to reach the farther planets. All right, so what we can tell about to summarize this experiment and example, back to the software product fit. So architecture is not the thing that kind of speeds you up. It defines how fast you go, how fast you can go. It defines what the friction between your product growth and the software that runs it. So it's about making sure you can keep building tomorrow. It's not about kind of today. All right, end of the example. I can get out of it. But now, you're probably thinking about one stuff I haven't mentioned at all, almost at all, right? And what about AI? Man, it's like 2026. All right, that's intentional. You know, I wanted to do some AI-less demonstration to show you how humans benefit from maintainable software. What are the examples of maintainability? Because even if you write code with agents, you still need to produce high-quality software. And actually, what we're going to talk about later, agents also benefit from maintainable software, not only humans. So, AI. Rails recently changed its pitch from idea to IPO, right? From prompt to IPO. You already know that, thanks to Sirdes. So the one-person framework is no longer the one-person framework. The person now comes with an agent. And we need to bring AI to the equation, right? Let's talk about AI. Let's start with this thing, also been discussed a lot during the conference. AI is an amplifier or a loot box, and it works like that, right? If you have good conventions, good architecture, good tests, whatever, good style, AI makes you faster. If you don't have that, AI creates mess faster. And that is the thing. Getting to 2 with AI can actually be harder than without it, if you let it loose and allow building roadblocks on the way to better maintainability and scalability. AI makes it trivially easy to generate technical debt at a rate humans never could. So AI needs special kind of care when we talk about these aspects of the software. All right. Oh, yeah. I already mentioned we talk about it a lot. AI echoes whatever you put into it. But let's talk about some other stuff. So what role does architecture play in the AI era? Does it even matter to have a better architecture? Well, I think there are 2 hypotheses. They're not statements, they're just hypotheses. First is context compression. When you have structure, like in our filtering example, or when you, for example, have an authorization layer with policies, the agent only needs to understand the layer to introduce changes to the logic that is backed by these layers, right? Not the entire system. But, well, what's the problem? Like, we have models that have 1 million context windows. So does it still matter to keep the context small and the logic cohesive? Maybe, maybe not. But the fact that AI has now huge context windows doesn't mean they use the whole context window for purpose. AI is good and decided, oh no, I understand everything right now without reading the whole picture, and it's going to work on that. It doesn't check everything when there is no structure. And when there's no structure, no boundaries, there is no good signal for AI to stop exploring, stop collecting the context. It actually happens pretty much randomly. Well, unless you have a very tiny code base and everything fits the code base. But we're talking about the stage of the growth, and the code base is probably not that small. So having 1 million tokens doesn't help if the agent never reads the right ones. And another aspect of architecture related to AI is that actually architecture introduces kind of implicit hardness. you don't need to describe everything in your agents MD or add rules and so on. AI is good in following conventions and following style. So the more conventions you have in code, the more examples, and they're consistent. AI would likely use the same pattern next time it needs to build something like that. But the problem again, what we introduce here, like what I introduce into the code base, these new layers, new concepts that are not vanilla Rails, that are additional layers of abstractions and additional levels of indirection, why am I sure that AI would benefit from that? Because, well, maybe AI is better in dealing with spaghetti-like code and a mess, and that's it. They can understand that. They're not humans, anyway. So to answer that question, if abstractions help, like layers or whatever architecture you use to separate concerns, help AI to generate better code or not, we need to run experiments. That's the only way to answer the question. And again, we talked a lot about experiments at this conference yesterday and today, and I remember that. Okay, let's try that. DeepSeek. 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 Bravo. All right. I hope you're not recording that. I'm traveling to China next week. All right, yeah, we already know about experiments and some ideas behind them, but I still want to show you mine. It's very tiny, but it has some interesting stuff in it. So, back to the project. So I decided to, well, I have a code base, I already worked with it, I did some refactoring. I decided to reproduce the feature that was failing when I joined the code base using AI and different versions of architecture. So one is kind of a vanilla Rails at the back end, and another one layered with filter objects. So I removed the feature, cleaned up the history, created 2 branches, and so on. Same prompt, same process of building a feature, and then the evaluation process. Let's talk about the numbers first, just pure numbers. So both kind of AI was a bit better architecture to my taste, and without it, produced no bugs. That's good. So the bug and the mistake, what's the difference? Bug is something that breaks the system. Mistake is something that should not pass code review. It's some very bad code or whatever. I'm going to show an example now for you to understand. So that's a new version of this controller. Now we have some explicit kind of case when statement with all the sort field iterated. And AI decided to build this kind of a subquery, arrow, whatever, for sorting by the completed lessons count. The fun fact is in the prompt, I don't think you noticed that, there was an explicit mention that, okay, we sort by the completed lessons count column in the courses field. So you don't need to write anything like that. There is a column. You don't need to join or whatever. And the corresponding version in the filter, like in the layered version with filter object, is just adding a single word to a filter object. Oh, now we know now we can sort by this field too. Because AI understood, oh yeah, okay, there is a pattern. We just look at the database table columns, see if there is a table, we just add it to the list, if there is a column. If there is no such column, we figure out, oh, what we need to join and build some query. And that's, I call a mistake. So both work, but that's the code to the left is not the code you would like to keep in your code base if you expect, some product market fit. So also, there's another perspective on these 2 versions of the same feature, and that's a perspective, again, I borrowed from the Rodriguez talk yesterday. I like this evaluation plan, so I put all the logs from my generations to it. And it also told me something interesting, that, well, we have this invented new patterns in the unlayered version, we have more lines of code changes, and so on. So for every criteria, well, at least to this evaluation framework, layered version worked much better. So does it mean that, well, we improve kind of a more I would say, sophisticated architecture that adds boundaries and so on, make AI agents smarter. Well, no, nothing makes them smarter, but that makes the mistakes smaller and more rare, and the correct code that produced, it's kind of cheaper in terms of conceptual overhead, in terms of tokens, in terms of lines of code. And that's actually what we need to worry about the most. But implicit hardness, which is provided by architecture, is not enough. Because, when we don't have rules, guidance, written guidance, guardrails, or whatever, our overexcited agents can still turn our code base into a mess. And let's talk about the concept of pattern-oriented architecture. It's an old one, and there used to be a book about that. That kind of builds a hierarchy of patterns in your code base. It starts with idioms, so it's like at this very smallest level, right? When you write, I don't know, like it's something that, like Rubacop performance, for example, fix automatically, right? How to write more efficient, more safe code by default at the local within the function. Then we have design patterns. It's like all the value objects, whatever stuff that describe the interface of particular object and their responsibilities. Then we have architectural patterns. It's a higher level, how subsystems communicate with each other, and so on. And now, in 2026, I think that part stays. It doesn't go anywhere. But we have a new layer on top, and the naming sucks, but I call it AI orchestration patterns. So that's kind of the patterns of herding AI agents, let's say. And that includes, well, today. It's probably going to change in a few months, but as of today, it's all the skills, rules, hooks, and so on. That's something that's also called harness, right? It's how we guide our agents in writing code. But that's not the only thing that has changed. The other thing that has changed, not just a new level of kind of software development practice, but also the involvement of human at each level has changed. Like, we don't care about writing idioms anymore. AI is good at that. It can fix that and suggest whatever. Design patterns is also handled pretty well. Well, when it comes to software design and architecture, I would suggest paying more attention by meet agents to that. And with AI, we mostly on our own today, but we can use AI to orchestrate AI. But I would be, well, there is still some level where AI is not involved, right? And it always exists. So there is always something for us to do, right? We want, back to something that also been said at the conference, we're not going to be replaced by AI, but we're going to do a bit different work from now on. And that work includes, that's actually what we now need to do in addition to writing code, maybe, or generating code, or keeping it maintainable, thinking about architecture, and so on. We also need to guide our amplifiers, because we need to make sure that not only the quality code goes in, but the quality context, and that combination will result in the quality code out. And that kind of includes many things. It includes the processes of working with AI. And I'm mentioning here the compound engineering plugin, which is not just a plugin, it's also kind of a methodology of building with AI. It's not the only way, but it's a combination of planning, reviewing, working, reviewing, compounding, and so on. That process works really well, and such processes, like such methodologies, will appear, I'm pretty sure, a new one and with some other ideas, but that's new level of coming up with new ideas. Also skills, of course. Yes, I'm advertising my own skills, which is basically the book already mentioned and lying here, turned into a skill set. So it works very well, especially for smaller applications. So you have all this complexity of layers right away. But first read the book, please. We have context enrichment tools, and we have something I call trusted references. That's kind of new stuff I added here. And that also has a story behind it. And the story resulted in the upgrade of the gem file of Dreams gems that's just been published an hour ago. That's an old gem of my blog post of mine with some curated list of gems and when to use them, what we use at Evil Martians. And that's a new major version. Check it out. Let your agent check it out, because I found, working on some of the code bases of our internal projects, that agents are very good at reinventing wheels and using, like writing sophisticated custom implementation of things that could be added with just one good, tested, production-ready gem. And I think that's why I added trusted references. We need examples of libraries and how to use them. We need reference code bases, and luckily we have some. We have a lot of from 37 signals. We have our Evil Martian Red Prince series, and so on. Like not just code bases of the good old monolith projects, like, I don't know, Mastodon or Lobsters. Some smaller code bases that has no generational issues and legacy code that could be used as reference examples, right? If you use a code base that has a lot of, technical depth as reference examples, you probably know what you get as the output, right? And blog posts, some collections, curated collections of gem, or Ruby Toolbox, for example, is a good resource for letting your agents pick something that's maintained, has downloads, which is not the best metrics, but still, it would be nice to have a AI layer on top of Ruby Toolbox, right, to let Ruby agents to search through the gems and libraries to pick the one that works. So, okay, that's about AI and guiding the amplifier and so on. And we have just 2 minutes left, and that's fine because I have just a few slides left. I want to do a quick recap, and it's kind of what makes up the point 2, right? So we talked about maintainability. We talked about a little bit actually about AI and how that affects. That could be a friend and a foe of your code base, and that's not all that comprise into the things that you need to think about before building a stable foundation for the future growth. So point 2 is the foundation that keeps your product alive and striving for a long time. It also includes the platform, how you deploy, how you deliver code, your observability characteristics, and so on. And the processes in your team, how you coordinate, how you ensure security and best practices, how do you onboard users, for example, by providing consistent dev environments. That's also a part of getting from 1 to 2. That's all the blocks that you need to, the pieces of the puzzle that you need to fit to build a stable frame for the future development of the product. So let's recall them once again. That's the most security aspect. So, security. Security is not mentioned here because it's everywhere. So, yeah. So that's what it is, the point 2 for the software project. And coming back to space history. So we talked about the first 3 steps. And one idea I would like to share here, that actually why I think that this 1 to 2 transition is most important, actually, because it works as an induction step. So you have 0 and to 1 is your base of the induction, and 1 to 2 is the step. And that kind of proves that your product can grow if your product market fit increase. That's why it's the most important one. And where are you going to be grow? What's your destination? It's definitely not point 2. It's much further. And depending how good is your foundation, that defines how far you can get. So, quick recap of the main idea we already talked about today. So the product cannot grow your code base, right? You need to keep the gap between the product growth and the software quality characteristic and performance characteristic in sync. You need to keep monitoring the gap between them, right? Like we saw in the chat. So that's the main idea. Mind the gap. Don't forget about it. Don't focus on product when it grows faster. You need always to keep in mind that the code base must catch up. And there are some ideas how to prevent that gap from growing, or at least identifying it. And there are just some ideas. Well, you can just analyze your code base, your software, using different tools. By example, this is an example, like we have a skill and layer rails skill set that analyze your code base based on the kind of ideas from the book and the layered architecture and so on. It gives a lot of food of thought. Just give it a try, actually, and share with me. I would love to see it. Well, it's not necessary to fix all of that, but it can highlight some of the problems that could blow up later. Another important thing is reflection. So it's something that we had in my ticket example, right? I didn't just fix the bug. I decided to figure out why it happened and why we should do that. So do some regular retrospective of the bugs you fixed, of the PRs that took months to merge. That's a process problem. And see what should be improved. And of course, performance-wise, monitoring is required as one of the key aspects. And follow us, because we actually work with this category of projects, of startups, for 15-something years, and the amount of experience and knowledge, which is still relevant. It's even with all the AI stuff, you cannot replace dozens of years of expertise of good engineers. And our goal, I think, to become such good engineers and teach AI how to write things and not the opposite. All right, thank you very much. That's it, I think, for the conference, and I was